Namaste. Today I'm changing the location a little bit. We're going outside on the Bandra seaside, and the new coastal road getting constructed over there on both sides is going to get connected. And at sometimes this entire area is filled with water. And today is a low tide, and so therefore we have a lot of space here to sit and do a little talking. Today I'll talk about one of the things that I keep referring to whenever I talk to students. That so when I was doing my graduation at my BTech days, that almost 40 years ago, we had one bunch of topics to study. So and today, when somebody who is taking a BTech in IT or computer science, that time there was no IT and computer science; it was primarily computer science. And so today, if you look at people have another bunch of or one bunch of subjects to study. What is the difference between these two? To a lot of things that we are teaching students today were not there when I was studying at that time. And languages have changed, and also technology, the development platforms, the computer technology that we have, they have all changed a lot. Those times there was no laptop, there was really nothing to call a desktop. Also, it was mainframe based computing and with the client machines, if at all. And if you look at languages, I think I started my journey with Fortran, and then towards the end of my degree I did Pascal. I'm over a period today, most people are working with Java or .NET, Julia, Python, so many other languages. And so if sometimes we look at and say, oh, so much has changed, what I have studied there is useless. Today we have a completely different set of topics to study. So you might think that there is so much of change. But there was an article which I read long back, which said that there is a set of core concepts which actually haven't undergone any serious change at all. So if you look at the core concepts of programming, that still remains. Almost every programming language that is widely used today have assignment, conditionals, branching based on conditions, loops, input and output, and that's the core of programming. Everything else is peripheral, additional structure that is created to make things easier, and there was also function calls or procedure calls to create modular or structured programming. And if you look at the dominant data storage mechanism, that is still relational databases, and that's the same SQL, structured query language, that I studied during my degree days. And pretty much the same language goes, and the relational algebra that is driving it, that we are teaching students, is also quite same. And how do you debug a program? There is a lot of good GUI and all that is available to trace how programs are getting executed, but ultimately how the way you create models of what the program does and how you debug remains more or less the same. Right? So you need to understand the logic. You insert either print statements or tracks or traces, or monitor the variables, and you do the debugging. So, and another important area is operating systems. We had a relatively primitive operating system that time. There was Windows, and all the GUI based systems were yet to come. But we had the core Unix based operating systems at that time. And Unix is also not a lot that has changed, although the variants of Linux and all that has become very popular today. But the core OS book, if you look at, bulk of that remains the core algorithms, the core concepts of memory management, CPU management. How much has that changed over the last 40 years? So And another important area that is, which is very important for computer science students is data structures and algorithms. I have studied at that time stacks and queues and linked list and binary trees and even AVL trees, and that's what predominantly a data structures course today also consists of. So what has changed is predominantly the syntactic sugar that goes around these the interfaces. You have much more fancier graphical user interfaces. You have mouse-based controls. You have touch screens. Interacting with the computer has become much easier, but a lot of core concepts are not actually changed. If you look at programming, or if you look at operating systems or data structures, or those concepts, if you look at it from this angle of what is the core of this, you will actually find that you can actually switch or move with the technology much easier, because what you are seeing is that the same concepts with a different syntactic sugar, a little bit of different terminology, actually allows you to sustain life through much longer. So it is this idea that even computer science, despite the very drastic changes that we talk about over the last 40 years, the underlying, pretty much like the here, at some level it's full of changes. There are waves and there are changes, and the water rises, falls, etc. But the core concept of this actually hasn't changed over the years. And that there are core concepts which is actually pretty much being invariant, allows you to move from as the technology changes, to adapt yourself to newer things as they come. If you look at like many times courses are taught, if you look at it primarily from the syntactics. So for example, a lot of people think that object-oriented programming is what Java does. Java is just one way of implementing object-oriented programming, right? There are very different ways of implementing the object structures and inheritance and operator overloading, method overloading, and all that other languages do. Like object-oriented Lisp, for example, has a very different flavor to it, but it's the same concept. The same concept of one method with different signatures which are used to overload, or one method which is attached to different classes, which provides the variations in behavior. So how you do these details is something that might change with the time or change with the language, but the whole concept of defining classes, objects, and attaching behavior to this, it has actually not changed a lot there. So recognizing the core underlying structure allows you to look at the field with much more stability than what otherwise what appears to be. At the same time, you should also understand that when the outer layers change, you will need to adapt. So if you say that I will only do command line programming, or text interface programming, then it is very difficult for you to sustain today. So, but recognizing that this is only a syntactic sugar or an abstraction on the input-output layer, allows you to switch to these things much easier, and that is how people like us over a large horizon of 30-40 years have been able to stay in the field and still do a lot of work understanding this commonality. Okay, so that is something that I think every computer science person or IT person should understand, that there is this common and conceptual layer which is invariant over a period, but the outer layers which changes. So that adaptability becomes then much easier. Okay, so take care. Have a good day. We'll meet another day. Thank you.